who this morning came here with public transport? Okay, great. Who came here with his or her own car? Fantastic. Who took an Uber? Wow, all public transport? Impressive. Very cool. That's great. So all the people who have taken their own car were probably stuck in a traffic jam. All people who took public transport were probably stuck in a very, very busy tube. And this is the issue, right? I mean, transportation is broken as we move around today. We're wasting billions of hours every day stuck in traffic jams, stuck in non-optimal transportation. We have full, crowded subway trains. We have people who are spending hours commuting every day from their home to the job, and they barely can pay the cost for the rent they earn from what they earn for the rent and for the cost of moving where they live to where they are able to get a job. And the question is, how do we fix this, right? How do we fix this transportation? How do we fix human mobility? And in order to fix this, we need two things, right? One is we need AI. We need AI that understands how people move and how we can improve it. And the second thing is what we need great data to train our AI systems about how people move around and about how we can improve how people move around. And this is exactly my key statement here today, is with the right kind of data, we can train AI systems that make us move around more efficiently and get us to our destination faster and more conveniently. And then the question is, what is this data? Where do we get the information, how people move around today? Where are the bottlenecks? And how we can improve how we move from A to B. And if we take a step back and think about, okay, how would I go about it and find out how people move around today? Well, basically, there are three options. One option is Apple iOS. Apple has a very, very comprehensive understanding of how we move around. The second source is Google Android. Google has a very, very deep understanding of a big portion of the population, how they move around every moment. Unfortunately, both sources are not really a good source to understand human mobility, because Apple and Google have their own business models and will never share this kind of data to understand how people move around and to then allow us to improve how people move around. So what's the third option, right? How do we understand human mobility on global scale to improve how we move around? This third source is telecom network data. And I'm just showing you here a few examples of telecom network data. This is the data being generated by your phones in your pocket, no matter whether you use them or not, no matter whether you carry a smartphone in your pocket or an old feature phone. This data is being generated by phones switching between cell towers, and this data being piped into the Teralytics engine to understand how people move around on a global scale. We are currently covering the mobility of 500 million people globally. We're in the US, Germany, Austria, Spain, Singapore, and Hong Kong, and are scaling to 1 billion people in the course of this year. And this data is the key source, the only available source to understand how we move around, what mode of transport people take, who takes the subway, who takes the car, or even who takes an Uber or who takes a DD. Because the carriers also happen to have access to the usage of apps on your phone. This data is all aggregated, anonymized. So this is not about you as an individual. This is always grouped together into groups of people, because when you want to make decisions about how we design our transportation systems, how we design our future of mobility, you don't need one person's mobility. You won't build a train track because of one person. You will build a train track because of a few thousand people wasting time every morning commuting to work. And Teralytics is ingesting this kind of data, anonymizing it, aggregating it, and is turning this into useful information for public transport operators, for ride-sharing companies, for car OEMs, for anyone who's in the business of moving people around. And for example, this one here shows you a train in Singapore. These are subway trains in Singapore, real-time movement of trains. On the left-hand side, you see an autonomous train manufactured by Alstom. You see very nice pattern of trains moving across the stations over time. On the right-hand side, you see a human-driven train. Very, very chaotic picture. You see the benefits of having an autonomous train running around. And we can, of course, overlay, thanks to capturing mobile network data from telecom carriers, we can overlay how busy each train is between each station, right? We know exactly at the moment right now how many people are in which train every given moment. We know exactly how long it takes people from their home to the next subway stop. Should we offer bike sharing? Should we offer on-demand ride sharing for people who want to use the subway stop but need to walk half an hour to reach it? We also, for example, understand how many people are standing on a station, on a platform at a station and are unable to board because the trains are just too busy, just too full. So summarizing, using telecom network data as the only source to understand human mobility on a global basis, we are working towards the goal to bring everybody home faster and make sure that the currently broken transportation systems around the world are being fixed. Summarizing, we are using AI, sourcing data from telecom networks who are partnering with us and provide us anonymized data to understand human mobility. We are informing how we build smarter cities and mobility. Thank you very much.